All right, section 2.7. We're talking about solving equations graphically. A part of this section is also finding intercepts. So we're going to start off talking about intercepts. I'm also going to start off, or following the intercepts, I'm going to talk about zeros of a function and roots, and that will all be leading up to how to ultimately easily solve equations graphically. But I don't want to just give you that process without helping you kind of understand why that process works, okay? So we'll talk about intercepts, and then I'm going to explain a few things that will lead into ultimately solving equations graphically, which will be the last problem, okay? So let's talk about finding intercepts, though. To find the x and y intercepts in a function, you've probably done this at some point, maybe in Algebra 1, but to find the x and y intercepts, this is what you need to do. The x-intercept will occur wherever y is 0. So if you think about, here's the x-axis, right? Whenever y is 0, the graph will be crossing the x-axis. So for instance, if the x-intercept was at 3, 0, right? Suppose it was there. It's not, but suppose it was, right? If it was there, then the x-intercept would be 3, 0. That is, y would be 0. Okay, so in order to find the x-intercept, what you need to do is set y equal to 0. To find the y-intercept, you do the opposite. So wherever the y-intercept is, x will be 0, right? Because it'll be along the y-axis here, where x is 0. Okay, so to find the y-intercept, you set x equal to 0. Okay, so remember that if we have a function f of x equals 2x plus 4, we can write that as y equals 2x plus 4 for our purposes. That's totally fine. Excuse me. So to find the x-intercept, we can set 0 equal to 2x plus 4. When you solve that, you'll get negative 4 divided by 2, which is negative 2. So x equals negative 2. So where's our x-intercept? It's right here. How about the y-intercept? Well, that's if you set x equal to 0. So if we do that, we will get y equals 2 times 0 plus 4. That's just y equals 4, which makes sense because we always say that this is the y-intercept in a line in slope-intercept form. So there's our line and there's our intercepts. Okay, so that's actually another quick way to draw a line. If you want to do it that way, is you can just find the x and y intercept and then connect them. Okay, so that's how you find the x and y intercepts. In this graph, we want to find the x and y intercepts, and you can do this. I've already given you the graph, but you can put this in Desmos, or you can put this in your graphing calculator and figure it out that way. X-intercepts, you can see clearly from the graph here, well, sort of clearly, is at negative 1, 2, 3, 4. So our x-intercept is at negative 4, 0. All right, and our y-intercept, oh, sorry, there's two x-intercepts. So there's one at negative 4, 0, and then there's another one, 1, 2, 3, at 3, 0. Okay, so there's two x-intercepts on this graph. There's a y-intercept here at 0, negative 1, 2, 3, 4, 5, 6. So 0, negative 6 is the y-intercept. Okay, again, x-intercept where the graph crosses the x-axis, y-intercept where the graph crosses the y-axis. When you graph this in Desmos, it's as simple as clicking or tapping on the intercept and the point will pop up. It's not quite as straightforward in the graphing calculator. Let me show you real quick. If you put in 0.5x squared plus 0.5x minus 6, you will get the graph that looks the same. And sometimes you can see it perfectly from the graph. Sometimes you need to do, to find the intercepts, you need to use the zero finder, okay? And a zero, as we'll talk about in a second, is the same thing as the x-intercept. So what you do first is you pick a point to the left of whatever intercept you're trying to find. So I'm trying to find this one here. So I pick a point to the left of it, hit enter. Then it says, what do you want for the right bound? Well, you arrow over to the right of your x-intercept, and you can see that this is my x value for the blinking point right here. Hit enter once you get to the right of it, and then take a guess. So get sort of close, hit enter again. It will tell you that the 0 is at 3, 0. The x-intercept is at 3, 0. Okay. So that's how you find intercepts. Let's move on to zeros of a function and talk about that. The x-intercepts of a function are values that make f of x 0. In other words, they're the x values that make y 0. Another name for those is the zeros, okay? So when you are asked to find the zeros of a function, the zeros of the function are the x-intercepts. You can think about those basically interchangeably for our purposes here, okay? So here, if we want the zeros in this function, the zeros are here at x equals negative 1, 2, 3, 4, and x equals 3, okay? Now, one little nitpicky type thing, these are the zeros. Usually for zeros, you put x equals. These are the x values that make the function 0. When you're asked for intercepts, usually you put the point. Okay, so you put negative 4, 0, and 3, 0 when you're asked for the intercepts, okay? So slight difference, but nothing that, you know, like I'm not going to mark you down on a quiz if you happen to put x equals negative 4 for an intercept, not the point. Okay, let's talk about roots now. Roots is a new vocabulary term, I believe. Roots, these are the solution to an equation. Sorry, I should just read this. The solution of an equation is also called the root of an equation, okay? So roots and solutions, those mean the same sort of thing, okay? So let's solve this equation algebraically and then compare it to its graph. Okay, so you should try this. You should solve this, and then you should compare it to its graph. So I'm going to solve this now. So I'll subtract 4. I get 2x equals negative 4. I get x equals negative 2. Okay, so the solution is x equals negative 2. Let's graph this and see what it looks like. Oh, we already have the graph. It's that line right there. Let's just sketch it out real quick again. And then see if you notice the pattern. The pattern here, if you didn't already catch it, is that the x-intercept here at negative 2, 0, the x-intercept happens to be the same value as the solution to the equation, all right, or the root of the equation is x equals negative 2, and it happens to be the x-intercept over here. What an interesting coincidence. Let's just pin that for now, and we'll come back to it in a second. All right, let's solve this system of equation by graphing. So to solve this by graphing, I know it feels like we're going way back to chapter 1 here, but we're going to solve this by graphing. Let's see what it looks like, okay? We've got y equals x plus 5. So, all right, here we go. Y equals x plus 5, so we'll put that in. Then we have negative x minus 3. Okay. And if I was solving this equation by graphing, what I'd be doing is I'd be looking for the lines cross, right? Where did they cross? Well, they cross right here at, put this in, it's bolder, at negative 4, 1. Okay, fantastic. So we'd say the solution to this system of equations is at negative 4, 1. And I don't know if we really need to sketch the graph there, but just that the solution to this system here is at negative 4, 1. Okay. All right, how about this system of equations now? Let's solve this. All right, 2x plus 4. Actually, let's go over here. So 2x plus 4, we already know what that looks like. We've graphed it a couple of times, so 2x plus 4. All right, and then y equals 0. So y equals 0. Okay, so let's look at the graph. Now, again, we're solving a system of equations. We're looking for the intersection of them. It's there at negative 2. Okay, so what should we take away from this? And we can sketch the graph of this, I guess, if just take a second. Okay, so there's your solution. It is at negative 2. Okay, so let's look. What I have found out is that if I want to solve a system of equations, this is review, by the way, solving a system of equations graphically, you graph both of them together and find where they cross. I also figured out that 2x plus 4 equals 0. The x-intercept of that graph is the same as the solution. All right, and then the last thing is that we just looked at is when I graph both 2x plus 4 and 0, where they cross is the solution here, is negative 2. So this is all leading into what is the shortcut for solving an equation. What I can do, let's jump down to number 2 here, is if I want to solve this equation, I can just graph y equals 0, the left-hand side of the equation, and y equals 2/3 x plus 4, and find where they cross. Okay? If I do that, that will definitely be the solution to this equation over here. But I can do it even shorter than that. an even simpler method. What I can do is just forget graphing this. Why don't we just graph this thing and find the x-intercepts? That will be the solution. That's what we saw up here, is that when we graphed it, the x-intercept happened to be the same as what we got when we solved algebraically. So let's do that. And this, by the way, this is the shortcut method, I guess you would say. This is how we solve equations graphically, okay? So all we need to do is graph 2/3 x plus 4. So let's do that. 2/3 x plus 4. So 2/3 x, x plus 4. Okay, and find the x-intercept. The x-intercept is there at -6, 0. So I guess if you want the sketch here, you could do that. It's plus 4, slope of 2/3. Okay, so it crosses at -6, 0. And then you can write, I think it looks like it zoomed wrong here. Then you can write that x equals -6. Again, the x-intercept, the x value there, that tells you the solution to the equation. So, to sum up, I know, again, I was just trying to kind of show you why all of this worked. To sum this up, though, the takeaway point is, if you want to solve an equation graphically, all you need to do is make sure that it's set equal to 0, and then graph this part, find the x-intercept, find the zeros in the graph, and that's the solution. Okay, so if you solve this algebraically, you should get to x equals -6. All right, and that's it for section 7.